So, hello everybody. I think the time is now 9 a.m. CET, so we will start the meeting, and it looks like most of you are here. But welcome to the fourth session of the Spectral Blue Autumn 2024 webinar series. We will start right now, and there is no, you will all be muted and no camera during this session. But if you have any questions, just feel free to pop them in the chat, and we will discuss them at the end when we have this Q&A sessions. I will be the moderator today, so if there's any issues, you can just contact me as well in the chat. Next, I will introduce the agenda, and today's agenda is we will speak about the food safety, of course, and Tuukka Autio, our product manager, will start with discussing blue light, how to prevent contamination in the food industry. And after that, we will have our global sales manager, Karin Henricson, and she will go into a couple of case studies that we have with regards to the food safety. And finally, we will have the Q&A discussion. So I will hand over to Tuukka Autio and let him start.
Thank you, Sanne. And good morning, ladies and gentlemen, from my behalf as well. Nice to see all of you here this morning. My presentation will discuss or will be an introduction to using blue lights to combat contaminations in the food industry. And these days, food security, food safety, these are hot topics. And there are several trends affecting these topics, such as the rise of antibiotic resistance, increasing regulation, climate change, and at the same time, all organizations are under the pressure to reduce the use of toxic substances, to reduce the use of chemicals that are harmful for people, that are harmful for the environment. And in the same manner, traditional ultraviolet devices that contain mercury will be phased out at some point because those hazardous substances have to be eliminated from the value chain. Regarding reducing the use of chemicals, it's becoming more and more difficult to introduce new chemicals into the processes. Old chemicals are being banned, and the same we can see in different use scenarios. But today, when we talk with food industry customers, I think we can distinct the different themes into 4 sections. The first and foremost being the well-known foodborne pathogens like Listeria and Salmonella, which can end up on the product, on the food product, in different stages of production. And this is the most concerning stuff for quality managers, because this kind of contaminations can lead to expensive food recalls, even up to factory closures. In addition to Listeria and Salmonella, there are other pathogens like E. coli, Campylobacter that our customers talk about. The second topic is maybe molds. For example, in the bakery industry, you can have instances of mold growth in the environment, and the mold can emit airborne spores that can end up on the food product and will cause shortened shelf life of the products. And on the other hand, molds can also affect grains even before harvest. So we have seen cases where grains growing on the fields get a lot of mold growth, and these molds can generate toxins into the grains, and the toxins can render the harvest unusable for human consumption. Then we often talk about infection control at farm level. So this means livestock, animal shelters. So on one hand, you have external effects coming from the environment, like pathogens such as avian flu can infect the livestock. Or if you have different buildings and you have people moving or goods moving between the buildings, there's a risk of cross-contamination, where you can move contamination or pathogens from one building to another. So that's a big risk for contamination and for the well-being of the animals. Then biofilms, the fourth topic, is a big one. So especially in areas where you have spills of water, you can have biofilm growth. And as we know, biofilm is really difficult to eradicate with traditional methods like chemicals or ultraviolet. And based on the latest research, the biofilms are not static. The microbes residing in the pathogen can actually detach, residing in the biofilms can actually detach and move to other areas of the facility. So we will talk a bit about that today. So of course, all these problems have been, or people have been trying to combat these problems with various traditional disinfection methods before, but all of the methods have different kind of issues dealing with safety, environmental unfriendliness, and unsustainability. I will not go through the whole list here, but the main thing, for example, with chemicals, it's that it's highly laborious. It requires a lot of human work. And the long-term exposure to these chemical fumes or skin contact with these chemicals can lead to long-term health and safety risks and health issues among the staff. Like I mentioned before, it's getting more and more difficult to introduce new chemicals, and some of the old ones are being banned. So that's a big problem. With ultraviolet radiation, the biggest shortcoming is probably the safety, because it's highly dangerous for people and materials, but it also generates ozone, and it can generate particle emissions indoors, which is not a good thing. And because these traditional UVC tubes contain mercury, they will eventually have to go away. Then you have different types of misting and fogging systems, but these need a lot of preparation, and you have to vacate the room, so they can't be readily used every day, so it's very cumbersome. So what is spectral blue then, and what do we do at spectral blue? So we create devices that emit multi-wavelength high-intensity blue light that kills microbes in the air and on surfaces automatically, while it's completely safe for people and materials. And in these photos, you can see how some of the devices look and how the room looks when the devices are active. We have devices for plug-and-play use that you can just carry into the room and plug into the socket. And we have devices that are built waterproof, and you can install them in a fixed manner in the ceiling or on the walls, or different use scenarios. So obviously, if you have a method that can automatically, without any user input, eliminate microbes from the air and surfaces, while being completely safe for the people and the environment, there are benefits in that. But on this slide, we underline some of the most important benefits that we think the system has for the food industry. So of course, the safety for people and materials is important. Blue light is not harmful for people, and it doesn't degrade materials. It doesn't corrode materials or destroy equipment. It doesn't cause allergies. It doesn't cause lung problems, etc. It's chemical-free. So basically, you don't get any of the shortcomings of the chemicals, and you can actually substitute some of your chemical use with blue light. It's UV-free, so it doesn't burn your skin, it doesn't burn your eyes, it doesn't generate ozone. Then an important aspect is the automation and the consistent performance. That means that as it's not dependent on the human operator and the light reaches even the small gaps in the room, then you get the same disinfection performance every day, 365 days per year. Always the same effect, same energy, same intensity. So you can count on the results. Blue light also can penetrate and eliminate biofilms effectively, unlike traditional methods. So that's an important aspect. And then I would like to highlight the economical aspects and the effortless use, because these are LED-based devices, so you don't have to replace any tubes. And they have a lifetime of up to 10 years, which means that basically they are install and forget type of devices. You just install it in ceiling once, and then you can use it for up to 10 years. And all you have to do is sometimes clean the lens if there's dirt or stains, so the light can come through. So what is visible blue light? If we look at the spectrum of lights, it ranges from the UVC, UVBA, and UVA bands into visible light and into infrared. So visible light means that those wavelengths between 400 and 700 nanometers roughly are visible to the human eye. That's why it's called visible. And we can't sense infrared, and we can't sense pure ultraviolet radiation. Visible blue light is in the range between 400 and 500 nanometers, and our wavelengths are inside this range or spectrum. The antimicrobic properties of blue light have been known for decades, and there are over 2,000 peer-reviewed scientific articles studying different microbes and showing that it works. On our website, we have a table with a search function. So if you need to know about a certain microbe, you can just type in a part of the name of the microbe, and it will return you a study reference. But how it works, so I will explain shortly. Most of you probably know how UV radiation works. So it affects the DNA and RNA strands. It breaks down these long DNA molecules, and that's how it inactivates the microbes. Now, unfortunately, the UVC radiation doesn't distinguish between human cells and microbe cells, so it does the same damage to people and animals. But the mechanism of action, how blue light works, is very different. It doesn't directly cause any damage. But this circle here on the slide represents a microbial cell. It could be a bacteria, a yeast, or a mold cell. And what's common with all of these cells is that they have light-absorbing compounds inside of them. And what happens when you illuminate these compounds with certain wavelengths of blue light at a very high intensity is that the compounds activate, and there starts a chemical reaction cascade inside the microbial cell. And as the end result of these reactions, highly reactive oxygen molecules called ROS, reactive oxygen species, are formed inside the microbial cell. Now these highly reactive oxygen molecules have the ability to break down all vital structures of the cell, including cell membrane, proteins, enzymes, DNA, and RNA. So when there's enough of this internal damage, the cell simply dies and the microbe is eliminated. The first most studied wavelength has been 405 nanometers, violet blue light. It was the first to be studied and first to be commercialized. And it activates one type of compounds called porphyrins. But we know this, that there are other compounds that can react to blue lights, and there are other blue wavelengths that can excite these other compounds. So our patented multi-wavelength technology is about combining the use of several antimicrobial blue wavelengths. And actually what's the big thing here is that the combined effect of using several wavelengths is not just 1 + 1. It's not an additive benefit or an additive effect, but it's actually a multiplied effect. So we get a much higher efficiency when we combine several wavelengths. And it also expands the killing spectrum of the method. In our first webinar session, which is available as a video, we have a more detailed description of the mechanism of action. So I recommend that you watch that one as well to learn more about the mechanism. Now there are some relevant laboratory tests or test reports available regarding our multi-wavelength blue light system and food safety. So I will just list a few of them. Last year, the University Clinic of Bonn did studies against several reference microbes. So the University Clinic of Bonn is a European reference laboratory that is involved in the development of EN standards and selecting these reference microbes. And they included Salmonella in the test. So you can download that on our website. Then a couple of years back, there was a master's thesis done at University of Eastern Finland, where the person studied the effect of blue light on microbes that were placed on food products and kept in cold conditions at +4 degrees. So that's a relevant study. And then 2 years ago, we did a study with University of Helsinki Virus Laboratory regarding the elimination of SARS-CoV-2, the agent behind COVID-19. And why this is relevant for us is because earlier it was thought that blue light has no effect on viruses, but now, based on this and several other studies, we know that blue light actually can eliminate viruses, and especially the families of viruses to which, for example, IBV and the avian flu H5N1 viruses belong to. So that's good news for infection control. And then one of the latest ones is from Atria, a leading Nordic food producer, who tested our blue light against Listeria in a biosafety cabinet. And my colleague Karin will later show you the results. Then a few words about biofilms. So this is a topic that has been more extensively discussed in our webinar number 2. So I suggest that if this is a topic that matters to you, then I recommend that you check out the second webinar session as well. But the good thing to know about biofilms is that they are typically very difficult to eradicate with traditional methods. And for example, with chlorine, you will need a lot higher concentrations than as normal. And UV light, for example, doesn't get through biofilm well. The good news is, though, that blue light penetrates several translucent materials like water, and it can also penetrate the protective layer of biofilms, and it can affect the pathogens inside the biofilm and eliminate them. You might need longer time and a longer energy dose than as normal, but if you use blue light in a continuous manner, that's not a problem. And this then brings us to my last major topic today, which is continuous disinfection. Continuous disinfection is kind of a new way of thinking about disinfection, what we want to try with Spectral Blue. Now, on the left-hand side, you have a graph showing how traditional disinfection performs typically. For example, if you use chemicals, they are quite laborious to use. It takes a long time, so you can typically do one chemical disinfection round per day. And when you start doing it, there has been a full day of working, and the contamination levels, microbe levels can be pretty high. And what you want to achieve with the chemical is really steep reduction, 3 or 4 logs in a matter of minutes. And many chemicals can do that, and that's great. But what people don't often think about is that there are 24 hours in the day. So even if you get the levels down almost to zero, then what happens afterwards when people go back into the room and start going about their business? So what happens is that the microbes start to grow, and eventually they will reach back the same level as they were before. So in effect, you have a short period of time during the day when you have really good hygiene level, and afterwards it can be something different. Now with blue light, the thing is quite the opposite. On the right-hand side, you have a graph showing the performance of blue light. And the blue boxes here represent the times when blue light is active, and the white gaps are times when it's not active. So if we start from zero, if we think that this is the first day that we install blue light, then we might start from the same high levels as you would with chemicals. We would run blue light for several hours. We probably wouldn't get everything at one go, but we would bring the levels down by 90% or 99%. There are still some microbes left. It's not as fast as chemical. Something might be left. Then people come into the room, they start working there. In the same way, the levels start going back up. But as soon as the people leave the room, we can turn the blue light on automatically, and it starts pushing down the levels again. And this cycle will repeat several times during the day, many times during the week, and very many times during a month. And eventually, you will push down the levels and when near to zero, and the microbes never have a chance to grow back anymore. So you will keep the levels down 24/7, 365 days per year. So we kind of turn the contamination curve upside down, and we never give the microbes a chance to grow back again. That's what continuous disinfection is all about. So as a quick summary, what can Spectral Blue do for you in the food industry? So first of all, we can help you to eliminate microbial contamination in production areas automatically and continuously. So this will reduce the risk of recalls and food poisonings. We can eliminate mold issues that may reduce the shelf life of products. We can help in improving infection control at farms, and we can help you eradicate biofilms. And overall, we can help you reduce your dependency on toxic chemical disinfectants, which will help you improve the sustainability of your operations and increase the workplace healthiness. And last slide from me, how do we make sure that it works in your facility? That's because we always do a computer simulation of your room to ensure that, first of all, we have enough blue light power, enough devices, and we can finish our business in the given time frame that we have. So this way, we always ensure that you get a working solution before we install anything. And this can be done on a single workbench, or it can be done on a complex manufacturing facility. for every room. And our first webinar session has a more detailed description of this process, so I recommend that you go and watch that. And with this, I conclude my presentation, so thank you so much, and I give the stage to my colleague, Karin.
Thank you, Tuukka. So my name is Karin Henricson. I'm the Global Sales Director here at Spectral Blue and led to Taylor, and I will talk about some customer cases today. First of all, though, I will give or discuss a small introduction about recent figures, regulative steps and incidents, and after that we will go to the customer cases. So there is a new, really new study. So this article will be published in the Journal of Food Protection now in December. It's already available online. In this article, they have made an analysis of food recalls in the USA between years 2002 and 2023, so a 20-year period. And as you can see here, the big figure, so biological contamination stands for 48% of all of the recalls within the food and beverage business. When we go into the biological contaminations and have a look at the different microbes, we can see that Listeria monocytogenes and different Salmonella serovars stands for together for 85% of all of the recall caused by biological contaminations. Of course, these numbers can differ a little bit between different geographical regions, but I think for most food businesses, these are the two most common pathogens to try to fight. In the study, they also made some conclusions on where or why you can have these contaminations and what should be done. So when you have live bacteria and recalled food products, it suggests that your processing areas were not properly cleaned and sanitized. It also, if you have, and this is, it also says that if you have a lethality step in your production, then maybe the contamination should be considered a human or an operator error, but this can also be reduced by sanitation of the processing area. So you should seek the problem and destroy it. Then, of course, there is a third reason, and that is, of course, if you have a product coming into production, a raw material that is already contaminated. So that is more complex to fight against. But when we look at where we at Spectral Blue can help you, so of course, when it comes to the processing areas, there we can help you, like Tuukka already told us. And also if it comes to maybe it's a human or operator error, when you use automated and continuous disinfection, it also minimizes that risk. When it comes then to the primary production or to the raw materials, there we will see that in some cases, blue light can be of help also there. It is more complex, but there might be a benefit of using blue light even there. Something that has been discussed quite much in Europe the last few months is that there is a proposed amendment to the regulation of limits for Listeria in ready-to-eat products. The reason for this proposal of the amendment, change in the amendment, is that the number of cases of listeriosis in humans is growing. And in 2022, we saw 16% higher, that it was 16% more cases of listeriosis in humans than the year before. There has also been more deaths from foodborne infections caused by Listeria than ever before. So, of course, it is the authorities' responsibility to do something about it. If this is the right way, that is a different question, but this will affect producers of ready-to-eat foods, both in Europe, but also in countries where you export to Europe. So the biggest change here is that before, or at the moment, if you can show that that in the end of the shelf life of your product, the amount of Listeria do not go above 100 CFU per gram, then you can put it on the market. If you cannot to satisfaction show that, then at the moment, when the product leaves your production site, you should not be able to detect any Listeria in a 25-gram sample of that product. But this will change if this proposed amendment comes into force. And it means that throughout the shelf life of the product, you cannot find any Listeria. So it means that it's more or less a zero tolerance for Listeria monocytogenes in ready-to-eat foods. And of course, this will lead to more recalls probably, and that's why there is now a discussion also how to minimize the risk that you end up in a recall. And of course, again, we come back to the hygiene of the processes, the hygiene of the factory. And here we can help. Then if there is an outbreak, if there is recalls, of course, it can be very big implications for the company. So here we have one example from this year where a Listeria outbreak closed the plant in a small town in the US, and 200 people lost their jobs. So this is also, of course, a reason why it's very important to discuss these things and see what can we do to prevent outbreaks and to prevent recalls. If we go into Spectral Blue case studies, Tuukka mentioned that we have a customer called Atria. So Atria is a leading Nordic food company, and they have tested Spectral Blue in one of their biosafety cabinets. They use Spectral Blue in the biosafety cabinet on a daily basis. So this is a biosafety cabinet where they handle control strains. And to mimic the real situation, they wanted to see how Spectral Blue can kill Listeria monocytogenes from metal surfaces, so from stainless steel surfaces. And of course, if it works in the biosafety cabinet on the metal surfaces, it also works on other metal surfaces. So what they did was that they had Listeria monocytogenes in appropriate dilution series, and they applied them to metal discs. 9 of these discs were then evenly distributed within the biosafety cabinet under the blue light device. They also had a control sample, so something to compare with, a metal disc where they did exactly the same. They had the Listeria monocytogenes also on that plate, but they placed it in a separate cabinet under similar conditions, but shielded from blue light exposure. The 9 discs were then treated with multi-wavelength high-intensity blue light for 8 hours, from 9 in the evening till 5 in the morning. And this is also how they normally use the device in the biosafety cabinet. And finally, all 10 samples were analyzed according to the ISO standard to determine the number of viable Listeria monocytogenes colonies. The results were really amazing when we look at the Spectral Blue treated samples. So all the 9 samples exposed to multi-wavelength high-intensity blue light were completely inactivated with a viable CFU count of 0. But the dark control showed no reduction in viable CFU count. So these results, of course, demonstrate that Spectral Blue is highly effective against Listeria, and it can be utilized in biosafety cabinets to prevent cross-contamination when you handle control strains. and also to reduce the risk of infection to staff. But of course, now they have also shown that it works on metal surfaces, so it can also be implemented in other places where you have metal surfaces. The next case is from a food factory. When we talk about customers maybe having an issue with a contamination in their factory, not all customer wants to give their name, so that's why this is anonymous. But this is a food factory where they have 3 rooms next to each other. So first we have the oven room, then we have a cooling tunnel, a different room, and then it goes to the packaging room. So the situation before the test was that in all these 3 rooms, we had positive Listeria samples repeatedly found. And findings were especially between the oven and the cooling machines. So the test procedures they did frequent before and after sampling in each room. So they did PCR tests, and if that was positive, they made a confirmation on plate. And this was qualitative results, so not quantitative. So we will get either a positive or a negative. We deployed 2 Spectral Blue devices in the oven room under the conveyor belt, and they were used during the nights. And all other practices, hygiene practices, were left unchanged. And this is how it looked. So on the picture most to the left, we can see where the target is, so the floor under the oven's conveyor belt, so between the oven and the cooling machine. And this is where we installed the devices, so 1 device on each side, pointing at the floor. And here we can see the results. So the room with blue light was, here we could not find Listeria after the blue light. We had there was one occasion, but in all the other rooms, we didn't see any change in how often they found Listeria. We discussed already where to implement blue light, that it could be good in the production facility, in the processes where you make the product. What we do not discuss today, but I think it was in the clean room webinar, we went through also the rooms where you change your clothes before going into production, and the cut-off rooms before production. That is also a very good place to have blue light. Now we are going to the beginning of the food chain, so to the primary production. So this is from a poultry farm in Finland. It's a chicken farm, and they have 5 buildings and a total production capacity of 180,000 chickens. We did a 6-week test, and it was done in 3 of the stables to compare the effectiveness of disinfection methods in real-life conditions. And why it's a 6-week test is that once they get the really small chickens, they keep them for 6 weeks before they go to slaughter. So before the test started, they had cleaned all the premises very well to have a 0.0 to start from. So in one of the buildings, they had no disinfection at all. In one, they had chemical disinfection with Virkon S, which is quite widely used still in the, at least here in the Nordics, in this type of business. And they did that once per week. And in the third, they had Spectral Blue multi-wavelength high-intensity blue light, and they used them every night. So this is what it looks like. When you go into animal stable like this, it's actually, you go through a hygiene barrier. So when you come in, you have the entrance that they called the dirty side. Then you go over a hygiene barrier, you change your shoes and go to the clean side. And from the clean side, again, you change your shoes and go into the animals. So here they had the sampling sites, you can see on the picture to the right, and it was 10 times 10 centimeter squares where they did swabbing. And this was the same in all 3 buildings. And this is how they used the blue light. So they had 2 devices, both in the entrance and also in the control room. So the results you can see here. So this is totally colony count from the so-called dirty side, so the entrance. And we can see that with blue light, we really didn't see any increase in the total count. It stayed really low. Where we had no disinfection at all, we could see that with time it grew. So you had a bigger contamination in the end of the test period. And with Virkon S, we saw also some that it went up and then it came down a little bit again, but it didn't stay as low as Spectral did. Then when we go to the so-called clean side, we can see a bigger difference. Again, with Spectral Blue, we didn't reach really high volumes or counts of bacteria. But of course, where you had no disinfection at all, you could see that it was really high values. But also where they used Virkon S, we could see that in the end of the test period, it didn't really work anymore. And there is an explanation to this, and that's of course that when you have to keep the animals in the stable, you will have more and more dirt ending up there, and then of course it will come also to the clean room. So this just shows also that how important it is also to keep these areas clean to minimize the risk when you have different or you have several buildings, that you don't bring anything from one animal stable to the other. What they also did take sample on was Enterobacteriaceae, which is of course of interest within the poultry business. And here you can see that in the building where they had no disinfection, we had several occasions when they found Enterobacteriaceae. Also, where we had the chemical disinfection with Virkon S, we found Enterobacteriaceae. But where we used Spectral Blue continuously every night, we didn't have any single case of Enterobacteriaceae finding. There is one more case study, just again to come back to Listeria. So Seilab Oy is an accredited food lab here in Finland. They are providing services to the food industry and to agriculture. And they do contamination monitoring in their premises. And in one of these regular contamination monitoring, they observed that they had a Listeria monocytogenes contamination in the waste disposal room. So they increased their chemical disinfection, but they were not able to fully eliminate the contamination. So that's when they called us and said, now we want to try Spectral Blue. So what we did was that we placed a Berlin plug-and-play device in the waste disposal room, and it was pointed towards the known contaminations or contaminated surfaces. And in this case, it was in the autoclave, in the seams of the autoclave. And after a few days of use, the Listeria contamination could no longer be found. And so they were really happy with the solution. And now today they use it whenever they need an extra layer of security or they need to fight something. We have other interesting cases on our website. Of course, we have many different customer stories, but looking at the food safety, we have, I think Tuukka already mentioned that we have also been able to fight Fusarium molds and getting DON toxins down on grains. There is also a blog post on avian influenza viruses and blue light and how it works and how we can be of help also in the infection prevention. the key learnings of today. So I think it's clear that it's very important to have good processes and to minimize the human error. To implement blue light first in the areas with the highest impact. Also that automated continuous disinfection decreases the impact of human errors. And spectral blue multi-wavelength high intensity deployed in the right place under the right conditions will help you to maintain a good level of hygiene. And the technology works also in cold conditions, which is very important within the food production. And most recalls due to biological contamination are caused by Listeria monocytogenes and different Salmonella sarovas. And spectral blue multi-wavelength high intensity is effective against these organisms. So just here in the end, a few comments. So please follow us at Spectral Blue by Led Taylor on LinkedIn. We post all news there, and also if there are some new customer stories. Please also let us know in the chat or with an email afterwards if there is a specific topic you would like us to give a webinar on. And we are always interested in making more studies on food safety, so please contact us or our regional distributor to know more about becoming a reference customer. Thank you. And with this, I hand over to Sanne, who will now see if there are some questions in the chat.
Yes, thank you very much, Karin and Tuukka, for these presentations. Actually, there's coming quite many questions in the chat in, so that's really good. I will start from the beginning. One of our our audience has asked if it is how the efficiency against spore forming microorganisms how is blue light efficacy on that?
Yeah, thank you. That's a great question. I can start by saying that we haven't ourselves done many studies on spores, but from the academia, we know that there are from different parts of the world, there are different studies where microbial spores, bacterial spores, and mold spores have been tested separately. And there is evidence that it can be effective, but I think the doses are higher than with vegetative forms of bacteria. So you will need basically a longer time to get rid of the spores. Karin, do you want to say?
No, I think that is, and then what we have, of course, is from a customer on the clean room side who had issues with bacillus, and when they had blue light in the room before the production, they could actually get, let me see now, 90% less contamination inside the production. So we do have some from the real world, some studies as well, but we haven't academically showed it with our device.
Thank you. And then we have actually a couple of questions related a little bit to the same, that how does, no doubt about that blue light is very efficiently on flat surfaces, but how does it actually when there's a lot of instruments or the underneath instruments where the blue light doesn't reach, and different instruments with a lot of crannies and nooks where you can't actually clean very well. How does blue light work in that respect?
Yeah, that's also a good question. So of course, if there are areas where no blue light can reach, then there will be a zero effect in those areas. But blue light does reflect really well from white surfaces, from metallic surfaces, and the blue light rays will actually reach areas that human operator never could reach. So I would say that we still have better chances than a manual disinfecting agent in that sense. But in areas where you have shade or shadow, you will have a lower intensity of blue light, and that means that to get the same energy dose as on the surfaces directly under the blue light, you will need a longer time to have an effect.
And then there's the next question on how about if you have a 24-hour production line with personnel, how could this technique be used?
Yeah, but typically we try to avoid scenarios where people would be constantly working under the blue light. The blue light itself is not dangerous, but as you can see from the photos, or so from the photos, that the whole room can become blue. So it would be really difficult to work under those conditions because you can't see any colors and you can't see what you're doing, basically. And it could also be a workplace hazard that if you can't see well enough. So if there's a kind of facility that there is no chance to keep the blue light on for enough of time, then we just have to say that maybe in this area you have to resort to some other method, and we can look at other rooms.
Yeah, and what we have done to some customers as well is that we have made like a spot installation, that if you know that you, for example, have a specific spot in your production area, maybe there that you could have it on for at least part of the day if there are not people exactly there, even though they are somewhere else in the room. And then, of course, again, where you change your clothes, where there is a risk that you bring something into the production when you are moving people or moving material. That's also where we then could see if that could maybe have an effect as well.
Yeah, that's a good point. So if there's a problematic area, for example, a conveyor belt or a machine, then you could basically bring the blue light device very close to that machine. So it would be just illuminating in the machine and not illuminating the rest of the room. So that's one way to achieve disinfection in that kind of scenario.
Thank you. Then there is a couple of questions with regards to biofilm also, that often the biofilm is created in very soiled areas where there's also containing fat and other issues and hard to clean areas. How can blue light reach the biofilm in these areas?
Yeah, well, just like with other disinfection methods, I would say that you would first need to clean the normal dirt and stains away before you can reach the microbes. So blue light will not perform as well as on a clean environment.
Yeah, and blue light does not, of course, remove that you need to do normal cleaning, mechanical cleaning.
Yeah. There's also a question with regards to if the microorganisms can develop resistance to blue light, which also might be interesting.
As per today, we don't know. There's no known studies showing that. There are some that says that there might be microbes tolerant to blue light, but then if you increase the dose that you give to a lethal dose, they will die. So they are not resistant, but they can be that's also where we can see that different microbes can need a little bit of longer time or shorter time. But as for today, there are no studies showing that there are microbes resistant to blue light.
A question regarding blue light, if it can be used on water and in drains.
Yeah, again, an excellent question. And so far we haven't published any water tests, but some of our customers at their end are doing or thinking of doing water tests, and hopefully we get to share the results in a short period of time. But basically blue light, out of all light wavelength has the best penetration through water. So, for example, in tanks, you can reach, if it's not a massive tank, you can reach all areas of water tank and effectively disinfect it.
Yeah, and there are actually from Sweden there is, but they used only one wavelength, but they have shown that they could reduce the usage of chlorine in some pools when they had blue lights as an extra.
Yeah. So we basically know that yes, it works if you have clear water that blue light can easily penetrate, but we can't yet say that what is the appropriate dose, how much blue light needed for what kind of water volumes. So that's still something that we need to.
But this is also something where we are interested if someone want to have a project together with us or something. It is, I think, something that could be of interest for us as well to do with our devices.
I think we can manage maybe one or two more questions here. There's one, if there's any studies on mycotoxins in grains, especially if blue light has to be used in the preliminary grain handling facility where only grain is cleaned and grain storage is done. Do you understand that?
So the results we have and experience we have is when we have farmers who have grains and they are going to take them to the mill and they need to have the toxins, the fusarium toxins, DON toxins under a specific value. And they have used blue light either in combination with when they are drying the grains or later in the year when they are going to take the grains to the mill. So I don't really maybe understand the question, but we have experience. And here, of course, we have not had as an aim to come down to zero, but to come under the limit that they need to be at. But I don't know, maybe the one who asked the question can also be in contact with us if they want to discuss it more in detail.
Yeah. And so maybe one of the last questions here, how is there a way to verify the effectiveness after some time of using the blue light? And how would you know if it's not working properly?
Mm-hmm.
Yes, well, you can use the same microbial sampling methods as with any other disinfection procedure. So you can take swabs or you can use contact plates. Well, I think Karin here is more of an expert in this topic. So
so that's of course if you want with microbial tests to show it. But of course, because these are LEDs, you will also see if the blue light is not working. If one LED dies, you will see it with your bare eye. And also we can measure the intensity of the light.
Yeah, that's a valid point. So like presented, the UV radiation is invisible to human eye. So from a UVC device, you can't know if it's active or is it working at 100%. But from spectral blue devices, you can see with your bare eyes that does it look the same as yesterday. If there's a problem, the LEDs would go blank.
Perfectly, thank you. I think that most sums up most of it. So maybe we should conclude this. If I can see there's also a couple of comments that this should be a really good alternative to UVC. So thank you for that. That's very positive. We will. This session has been recorded, so it will be on our webpage as soon as we have it ready. But already now you can see some of the previous sessions that we had. There was an introduction to the blue light, and there were a session regarding clean rooms, and there were a session as well as how to replace the UVC tubes in laboratories. So those you can already see on our webpage. We have a final session, the 3rd of December, where the topic will be healthcare and ambulances. So if any of that is of your interest, please go in and register for that. But otherwise, thank you very much for participating today and for all your good questions. And if you have any further questions, please just contact you and we will get back to you with an answer. Thank you.
Thank you.
Thank you.
Have a nice day.